As was discussed earlier, EPA sets air quality standards for 6 criteria of pollutants. EPA does this through the Clean Air Act and delegates the authority to implement these standards to the states. Georgia EPD works to meet these goals through the Georgia Air Quality Act, which is a law that was passed by the state legislature. In the Planning and Support Program, the Planning and Regulatory Development Unit is responsible for developing rules that are included in plans that are sent to EPA. These plans show how the state will meet EPA's air quality standards and emission guidelines. So here's a high-level overview of how the rulemaking process works. A draft rule is created and presented to the DNR board. Then a public notice is issued, and a public hearing will be held. Once the public comment period has ended, all comments are addressed, and the rule is then presented to the DNR board for action. Once approved, it is filed with the Secretary of State. The next unit in the program is the Emission and Control Strategies Unit, which collects emissions information from industrial sources and estimates emissions from other sources. They use these emissions to develop ways to meet air quality standards. This unit also administers a grant to replace older school buses with newer, cleaner school buses. This graphic is an excellent representation of the different types of air pollution sources. In addition to collecting industrial source emissions, Georgia EPD estimates emissions from non-point sources based on population. Examples of non-point sources includes household furnaces and dry cleaners. You may not know how many gas furnaces or dry cleaners are in a particular area, but you can estimate that a certain percentage of the population has furnaces and that a certain number of dry cleaners are needed for that size of a population. And then you can calculate emissions from that. Modeling is another method that is used to estimate emissions, specifically from fires, which includes both prescribed planned burns and wildfires. From mobile sources, this includes on-road sources, which are trucks and cars and motorcycles. Non-road sources, which would include construction or farming equipment. And modeling is used to estimate these emissions. It is also used to estimate emissions from biogenics, which are naturally occurring pollutants from trees, vegetation, and the soil. By collecting emissions information, we can see that over the last 30 years, there has been a 95% reduction in SO2 emissions, the majority of which have come from shutting down or controlling coal-fired power plants. When you look at our NOx emissions, you can see that there's been a 75% reduction. These reductions come from controls on power plants and from EPA regulations requiring cleaner cars. Lastly, in the Planning and Support Program, we have the Data and Modeling Unit. This unit is responsible for modeling emissions from stationary sources to ensure that they meet all state and federal requirements. In this example of modeling ethylene oxide emissions, the concentration impacts from the facility can be seen at a very local level. In addition to modeling for permit applications, the Data Modeling Unit also models on a large scale to understand what is happening when different scenarios occur. The graphic on this slide shows that how a 50% reduction in NOx would impact ozone, which is one of EPA's criteria of pollutants. The 50% reduction in NOx emissions results in less ozone, which is indicated in blue in this graphic, and that means cleaner air. Finally, another type of analysis the Data Modeling Unit has performed is to look at odor complaints and try to determine the source of the odors. To do this, they look at wind speed and wind direction to see where the odors may have originated.